Okay, hooray! Welcome to the channel. My name is Victor and I'm going to be your anchor for this series. So I'm going to be starting the CompTIA Data Plus series on the channel. So it's going to be a playlist. We're going to have roughly around 30 training materials for the Data Plus certification. So CompTIA have quite a lot of certifications. CompTIA have also introduced many certifications to its arsenal. So CompTIA is a body that validates skill set for IT professionals. So this Data Plus certification is a new version. It used to be the Data Plus version 1 certification. They are retiring it and they now have the Data Plus version 2. So if you're a data analyst, you want to validate your skill set, so this is the right certification for you. If you're new to the channel, don't forget to subscribe. I have over 30 playlists on tech certifications on the channel. So let's get to the job. Now, we want to look at the Data Plus certification. We want to look at what it entails. We want to look at what it covers. We also want to talk about how do you prepare for the Data Plus certification. We also talk about the curriculum and everything that has to do with the exam. Now, if you pass this exam, you're going to be getting the CompTIA Data Plus credit badge. So this is what validates your skill set, and you can share this to your LinkedIn. You can have this in your CV. You can speak to your prospective employers about this badge and this certification. What kind of skill can you get for this certification? Basic statistics analysis, data access, governance policy, that's data governance, data analysis, data mining, data quality characteristics, and of course visualization. So if you use Power BI, if you use Tableau, if you use SPSS, if you use SQL, if you use Excel, if you use any of these tools, then this certification is right for you. Or if you intend to validate your skill set in any of these tools, then you want to be able to do this certification. And data is not just about using those tools. It's about creating insights from data so that people can have a better way to take decisions. Now, this is what a curriculum looks like. It's like 11 pages, quite a lot, but I have summarized it using the Notebook LM by Google. So we're going to overview this certification. Now, the certification is called the Data Plus certification. It's called the DA00002. So the version 2. So the certification currently now is in version 2. It has about 5 core sections. Don't forget, I've also done a comprehensive video that explains the entire 5 modules. So don't forget to stay on the channel. I'm going to be uploading them in the coming days. They're already ready, so just want to make sure they are fit for the channel. Then we'll spread them across the days. Now, the first thing you want to understand about the exam is that if you want to pass this exam is called the DA002. Most certification bodies have multiple exams for you to pass before you can get some certain kind of certification. Like Microsoft, for maybe the solutions architects, you might need to pass 2 exams. For CompTIA have what they call the stackable exams, or stackable certification. So for you to become, let's say, support engineer, you might need to pass Linux and pass A+. So for this particular Data Plus certification, if you want to have it, you just need to pass 1 exam. Just 1 exam, the DA0002 exam. Once you pass the exam, automatically you get this credit badge, right? Now the question is, how many questions are you going to have? So you're going to have maximum of 90 questions. You don't have more than 90 questions. Now, I've written quite a lot of CompTIA exams over the years. Now, if you are told that the exam is going to be maximum of 90 days, what's going to happen is that you might get 82, 83, 85, 84, depending. Now, you're not going to get more than 90. So if up to 90, you've not passed the exam, so what's going to happen is that you are out. So you're going to get anything between 80 to 90, but it's not going to exceed 90 exams. So CompTIA is going to pull up from all its bank of exam questions, and each candidate is going to have any number between that. Now, what kind of questions are you going to be having if you are taking this particular certification exam? You're going to be having multiple choice questions and performance-based questions. But this is what CompTIA have been doing for the recent exams. Most of the exams now have 1 lab, performance-based questions at the beginning of the certification exam, then they have multiple choice, either to choose multiple answers or to choose one answer. So expect that when you want to take this exam, you're going to have 5 questions at the beginning that are going to be performance based questions, which means that you're going to be given a scenario, you're going to be told to drag and drop, all of those kind of things, performance based. Then after that, you're going to get questions that have maybe 4 objectives to choose one, or maybe 4 or 5 objectives to choose like 2 or 3 answers, or things like except this, or which amongst these is part of this, those kind of questions. So that's the kind of questions you're going to be getting for this certification exam. So what is the length of the test? 90 minutes. So most entry-level certifications from CompTIA is going to be around 90 minutes. So for advanced exams like the CloudNet X, or like the Security X, or like the professional certification, the Pro Series, they are above 90 minutes. But this exam, it's 90 minutes. So if you want to take this exam, what kind of experience should you have going into this exam? If you have less than 1 year, 1 year to 2 years hands-on experience, if you're a fast learner and you can actively understand what the data science process is, or you can learn while trying to prepare for this certification, then you're game. On the channel, I have a comprehensive playlist about data science process, using Excel, using Tableau, doing data analytics is on the channel. You can check the playlist, and don't forget to subscribe. Now, if you are done with these certification exams, or you want to take the certification exam, what are kind of things that you're going to be having in terms of your skill set? Now, data analytics is about translating business requirements using data and seeing how can we make some kind of insights, how can we make decisions from data. So it has to do with business requirements, it has to do with business objectives. If I have a data set of, let's say we run a hospital, the hospital is going to have quite a lot of different types of data. So the question is going to be, what is our objective? What do we not want to know? What's our goal? So you have to be able to translate those goals and see how to draw that insight from that hospital data. Maybe we want to know how many patients are between the age of this and this, how many people need neonatal care, how many people need pediatricians, how many people need surgery, how many people need that's after the hospital treatment, how many people need care that's of patient, how many people need such kind of care. So we might want to get that particular kind of data from insight from that data. So you must be able to translate that. So data analytics is not just about plotting graphs, plotting charts. No, it's about making sure that we can tell a story behind the data. Then you should be able to acquire data, prepare data, then transform data. Like on my channel, I have like 2-3 videos that talks about how do you do a standardized questionnaire design. So in this certification exam, collecting the data, acquiring the data, also preparing the data, or what we call data pre-processing, transforming that particular data, also it's a very important skill set you want to have. When we say transforming data, what do we need? What do we mean? We mean that if you have data in a certain form that will not be so usable, you want to change, you want to transform, you want to convert. Let's say you collected data from different patients. We're using the hospital as a case study. People submitted their height in their form as centimeters, some submitted in meters, some submitted in feet, some submitted in different metrics. What we want to do is to transform that data into a simplified unit. So we might want to use meters. So that's what we call data transformation. So you transform that data in a format that you can now analyze. Then creating reports, dashboards. Most of my students have mentored over the years. Aside just them learning how to do business requirements, collecting data, creating questionnaires, creating pipelines for collecting data, transforming that data. One thing I also want to let them understand to do is to create reports, because your dashboard doesn't make any sense if you cannot create a simplified report that top executives can look at it and understand. Most of the times people don't understand all of those dashboard stuff, but as a data analyst, your job is to tell a story. When you tell that story, one way you can do that is by creating reports. So I will tell my student to create their reports and put that on Medium, on GitHub, on any of those platforms, just to tell a story about what is in that data set. You might have a data set of 50,000 employees. So the question is going to be, what's the executive summary? What's the goal? What's in this data? Can you do what we call EDA, exploratory data analysis? Can you do that? Can you now tell us what is behind that particular data? Can you suggest to us? Can you tell us what kind of actions we need to take going forward? That's what you call a report. Then you need to also visualize it. So the approach is going to be that you define your objectives, you collect the data, you clean it, you transform it. Of course, what do you do next? You visualize it, you create your report, and if you now need to do what we call forecasting or machine learning, then you can go ahead and do that. Then you also want to be able to apply basic statistics methods. So here we're going to be talking about t-test, z-test, chi-square, standard deviation, frequency tables, and all of that. Now, adherence to governance and quality standards. So you don't just want to have data without proper controls. You don't want to have data without quality assurance. You don't want to have a way to standardize how data should be managed, either at rest, in transit, while processing the data. So these are some of the kind of skill sets you're going to get while you're trying to work on this certification. Now, we're going to look at the different domain objectives. Though we have 5 of them: data concepts and environment, data preparation, acquisition and preparation, data analysis, reporting, then data governance. The most important one is data acquisition. Sorry, the most, let me not say important. Let me say in terms of hierarchy, in terms of weight, is data analysis. Yes, followed by data acquisition, followed by data concept and visualization. Then the last one is data governance. So let's look at the domain objectives. So these are the major domain objectives. So understand that it contains 20% of the exam. This contains about 22%. This contains about 24%. This contains about 20%. This contains about 14%. Now let's look at each of these. So I want to summarize most of the things you need to understand ahead in terms of preparing for the certification. The very first one is going to be, you need to understand data concept. So when we say data concept, a lot of things comes to mind. So you're a data analyst. You want to become a data analyst. So first thing first, what kind of data are you going to be dealing with? So data types. So there are quite a lot of data types. So but we can put them into two broad categories: relational and non-relational. So when we say relational data type, we mean a data type that is a table, but I maybe have multiple tables, and each of those tables are related by a common column. Take for instance, I have 3 kids, right? So these 3 kids I have, somebody else in my family, let me say one of my siblings, also have 3 kids. Now, if we write the names of my family tree, and you write the names of maybe one of my siblings, maybe my brother or my sister, his or her family, you're going to see that for these 2 tables, they are going to be related by some certain kind of another table. Let's say we have another table from my dad. Now, what's going to happen is that that table and these 2 tables are going to be related by my dad. So you see that these 3 families are related by a single dad. It's as simple as that. So it's relational. So when you want to kind of say who is my dad is going to be somebody else's dad. My cousin is going to be somebody else's cousin. So you have data that is kind of related. So think about it like when you have an e-commerce shop. An e-commerce shop is going to have tables of items they want to sell. So these items are going to be in a table that have the items, their prices, maybe how many quantity people bought and all of that. So this is like a product table. You might have another table that have to do with shipping. So the shipping department handles that. Now, in that shipping department, they're also going to have a product line. They're going to have, let's say, how many goods was bought, the address of who they want to send it to, and all of that. They don't need to have the address in this table that's just the product table that's typically internal. So you see that this table, product table, and the shipping table is related by what? Product, because you're going to have product here, you're also going to have products there. So that's what you call a relational database. Then when you say non-relational, it means that you have different tables or different data sets and they're not related. Now, you're also going to understand that you have file extensions. As a data analyst, you're going to be dealing with quite a lot of different types of data sets. So you have the comma separated value, you have the Excel, you have the JSON, JavaScript object notation, you have the text, you have the JPEG, you have the DAT. So these are different file formats and more. You also have SPSS, you have quite a lot of them. Tableau have their files. You have different file formats you're going to be using. Typically, they are just the file extensions of the different type of data you're going to be using as imported file or you're going to actually be exporting. Now you're going to have what we call data structures. So you can have structured data, semi-structured data, unstructured data. For structured data, you're going to have what we call tables and schemas, like what I just explained. For semi-structured, something that is not really structured, like you have videos, Twitter, tweets, and social media posts. Those kind of things are not structured. So of course, you also have unstructured. Now let's talk about data types. So as a data analyst, one of the first set of things you're going to learn in your data journey is going to be what are the different kind of data I am going to be using. Even for programmers, for software developers, they come in contact with this concept because you're dealing with data. You're actually going to be coding something or you're going to be using some files, you're going to be using some data. So what kind of data set are you going to have? The very first one is going to be string. So string is just textual data. So how do you classify it? So you say character or variable character. So you can also have numeric. In numeric, you can have integer, you can have decimal, you can have float. So integer, just 1, 2, 3, 4. Then decimal, you have a point. Float, you have like 0.9999, those kind of stuff. So that's, you classify that under numeric. Then you're going to have another kind of data that is called date time. So for date time, you want to have timestamp. Let's say you have a data set for e-commerce purchase on your website. So we might have the time that that particular person purchased that particular item. So it's going to have a timestamp. So the database is going to store the time the person purchased it. As data analyst, when we get this kind of data, we want to do a plot, for instance, to say at what time of the month do we have our highest sale. If we don't collect timestamp, then it means it's going to be hard. That's why most of the time, as a data analyst, it's not just about doing those charts and plots. It's important you understand what we call the entire data science process. I will drop a video description of what I did on the channel on data science process. Very crucial for data analysts. If you want to be a seasoned data analyst, you must be able to start from the very onset, from when the objectives, the data governance principles in terms of the core objective of the C-level executives, what it is, up to the time when the data is being consumed. So if you understand the kind of analysis you're going to run, so it now tells the kind of data you should collect. So that will now inform the kind of analysis that will be possible. Take for instance, I normally give these examples to students. There was a time we were trying to do some kind of campaign. So imagine you wanting to have, let's say, send emails to a set of customers or clients. Now, you send out a form, people fill those forms, and you did not collect email. So you see that the purpose for that data set is defeated. Or imagine you want to know the time of the year when you have the most sales, but you were not storing the time of purchase. That data becomes useless. Then you have Boolean. So Boolean is true or false. Then you have spatial data. Spatial data have to do with geographical data. Most times you have null values, you have large objects. At times you call them blob or club. So these are more are the different data types. So this explains what you call data concept. Now, you also want to identify your data sources. The question is going to be, where are all the sources that your data is going to come from? databases, APIs, websites, files, logs, data repositories. So these are the different ways you're going to have input of data. So at times, you can be a data analyst. I've explained that in my channel where I talked about the data analyst or data scientist roadmap or career path. So I explained who a data analyst, a data engineer, a machine learning engineer, a cloud data engineer. So these are different fields within the data space. So the career path you are choosing is going to tell where you're going to be playing, whether you're going to be interacting with APIs, whether you're going to be interacting with databases, or whether you're going to be at the end where all of these things are done and you just get that data and you now do your analysis. Or the analysis is done, you're now doing interpretation on reports and all of that. Now let's look at infrastructure concept, because for you to actually do all of this analysis, at times I will say when you're doing data analytics at a very basic level, you'll be doing that with your system, right? With your laptop, with your PC, even with your mobile, even on AI tools like Gemini, ChatGPT, and all of that. Now, but when you start doing data at a very high level in terms of millions of data sets or millions of data rows, you have million customers, your regular PC is not going to be able to handle such kind of data. So you need to now move that to the cloud. So that's where the cloud service provider now comes in. So like Google BigQuery, like AWS SageMaker. So you have these tools on the cloud that can help you deal with millions of data rows. So this is where the infrastructure comes in. So we're trying to say, how do we ensure, or how do we have a system that caters for us the entire data science process in terms of collecting the data, doing the analysis and all of that? So the very first one we're going to be looking at is the big three. So AWS by Amazon, Azure by Microsoft, then GCP by Google. So these are the three top cloud service providers. So you also have some kind of on-premise services, and we classify them as you either having a private, a public, a hybrid, a community, right, kind of system. So you have a private system when all your data is just within your premise, within your laptops, your PCs, your servers. Then it is public if it's going to be online repository like GitHub, like your website. Those data are in such a way that it's somehow accessible to the public, or the public can actually consume such kind of data. Then it's hybrid when you're combining both of them. Now, how do we do storage? So there are three ways we can do storage. So it can actually be as an object, as a file, as a block. So in cloud computing, these concepts come very, very handy, because it's not going to tell how you're going to store, also how you're going to interact with your data set. Then of course we have containerization. So here, this is an application of virtualization where we want to not have too much infrastructure communication, but we want to have a way where we containerize everything, and it makes it easier for us to move this data set, move this infrastructure between operating systems or between different cloud service providers. Take for instance, if you containerize your solution, it then means you could move them between cloud service providers, and it helps you interact better with your data. Now, we're going to look at tools. So our tools are going to be broken into 5 areas. So most of the time, somebody wants to become a data analyst. So you got to ask yourself, is this just about the tools? No. So is it about the tools? Yes. So the tool comes very handy in terms of, aside you understanding the data science process, you learning how to collect data, you learning how to do reports. The actual work is going to be done by you doing data analysis. So if you want to take this exam, or if you want to become a data analyst, you should learn how to use at least 3 softwares. And these 3 softwares should be in this order. You should learn how to use a basic analysis software that is GUI driven. You should learn how to use one visualization software. Then you should learn how to use one coding environment, or DBMS. So I'm going to explain. So for coding environment, you just need something that you can do queries with, right? So you have things like R Studio, you have Visual Studio Code. I think I have R Studio on this system, so if you're doing R, you could use R Studio. So if you're doing Python, you could also use Visual Studio, right? You can, if you're doing R also, you can also use Visual Studio. So you might need a text editor or a notebook. So for a notebook, I will normally use Jupyter Notebook or Colab. Colab is the online environment for, it's owned by Google. It's, if you're going to do data analysis using Python and you typically don't want to install anything on your system, you can just go to Colab, right? You can just go to Colab and you can get started and start doing coding in Python. Very straightforward, very easy. Just say a new notebook and you typically you can start working, right? So it implements an environment, a coding environment for you. It's trying to initialize and you can get right on track. So this is it. So if I say 1 plus 1, if I say 1 plus 1 and runs it, it's just going to output the answer, of course, as 2. So one thing Google have done also is to implement Gemini, that is AI, in most of their. So you see now that it's telling you that, let me just click on this. So it's telling you that this is a Python engine, right? It's running on 1 gig RAM out of 12 gig RAM. So my environment have been given 12 gig dedicated RAM to run. Then it has also assigned 100 gig of hard disk space. So I have a PyTorch Google Compute Engine backend. So this environment has been provisioned for me, right? If I run a premium version, I can get terabyte spaces. I can have hundreds of gigs of RAM to run anything I want to run. So I'm not limited by my current PC spec. So that's one thing when you run some of these stuffs in the cloud. So you see you have an environment. So you can say, okay, I want, give me sample data. So I'm using Gemini now within the Google Colab system. Give me sample data set for an e-commerce purchase sites, e.g. on eBay, right? So if I run this, it's going to like pre-populate a simple data set that is based on my command, and once it's out, I can now start running analysis based on that. So but it's going to be in Python. So this file format is IPYNB. It's called Jupyter Notebook file system. So I could rename this, I could call this test, I could save this, it's going to save as Jupyter Notebook and all of that. Okay, so that is notebooks. So that's what you call notebooks. Then you also have business intelligence software. So for business intelligence softwares, they will typically help you to do visualizations. So I've used them all. Tableau, Power BI by Microsoft, then Looker Studio or Looker from Google. They also have some packages and libraries. So most of the times these are owned by programming softwares or they are offshoots of libraries. So you have TDVAS, I think this is on R. You have that on R Studio. You have Pandas, so this is the Python library. You have Anaconda, that is like a, would I say, an environment, Anaconda. So you have Anaconda, which is an environment that you can use to like run both Python, both R, and a lot of stuff. Then you have programming languages. So for data analyst, I will always say that it's good that you learn one programming language. Is you can do SAS, you can do Python, you can do R, you can do Scala. The most easiest among them is Python. At the very early stage when you're doing analytics, then as you move on to machine learning and AI, it now needs more practice. Then for DBMS, you are looking at database management system. So the very simplest amongst them, or the easy to go to, is the SQL Server Management Studio. Then you have the MongoDB, then you have the Azure Data Studio. Azure Data Studio, I've used it a while. It's very simplistic system. It works with the Microsoft Azure network. So you could explore that. Now, another thing is going to be the AI concept. Now, we're looking at data. Without data, you can't have AI. So one thing we're going to also look at in terms of concepts for the exam is going to be generative AI, foundation models, deep learning, NLP, natural language processing, and RPA. Right? For Gen AI, we want to look at large language model. Gen AI, anything that's going to help you actually generate, summarize, export different data types. It's what you call Gen AI. Then let's look at the second exam objective, that's going to be data acquisition and preparation. Now, for a data analyst, it's not, like I said, it's not just about doing the analysis. You have to get ready for the analysis. You have to get ready for the analysis ahead of time. If you don't get ready for the analysis ahead of time, what's going to happen is that you're not going to have a good analysis to do, or the analysis that you're going to do is not going to make sense at the end of the day. So the first thing is that you need to understand your different acquisition methods. So how do you collect data? Are you going to be querying? Are you going to be doing extract, transform and load, or you're going to be doing extract, load and transform? How are you going to be collecting data? Are you going to be doing some kind of survey? Are you going to be doing some sampling? You have different sampling types. You're going to see that in the curriculum, and I've already done those training materials, so I'm going to upload them to the channel. So if you watched up to this moment, don't forget to like, don't forget to subscribe, don't forget to share. Then how do you actually optimize your data? Are you going to be doing indexing? Are you going to be doing parameterization? How are you going to be querying that data? Now, you're going to be doing SQL here most of the time, is when you're going to be doing either join, filter, or aggregation. We're going to explain that in detail in the training material. So now, most of the times, that's what we call data quality or data assurance or data validity. So this concept lie within we making sure that the data that we collect, they are data sets that makes a lot of sense, and we can rely on the output that we get from them. The very first one is going to be, how do we handle missing data? How do we handle duplicates? Somebody fills a form and he fills 2-3 times. Now we analyze that data and we count it as 3, whereas it is 1. So these are the kind of things you do during pre-processing. You do during preparation, before analysis. A lot of people want to do analysis, they just pick the data and you start analyzing. That's completely wrong. You're going against the data science process. The data science process says, define your objectives, collect the data, prepare it or pre-process it, analyze it, do dashboards, make reports, make insight, do machine learning, or you cannot deploy to AI. So the thing is that you have to ensure that you have a way to deal with missing values, duplicates, outliers. What are outliers? Outliers are like outcasts. When I say outcasts, I would say data that is an anomaly. Imagine you go to a university where you're going to have people at least from age, let's say 15, 16, 17, the way up. You don't have somebody entering age as 2-year-old. So that's an outlier. If you plot a graph, I'm not with my writing pen. If you plot a graph, you're going to see that you have data sets this way. So you see, if you plot this, you're going to have something like this. An outlier is going to be a data set that comes here or comes here. That's what you call an outlier. So this is an anomaly, and you want to make sure that you know how to deal with it. So we're going to look at that in the training. Then we'll have to talk about completeness validation, right? Then cleansing. So quite a lot of things to look at here. So strange manipulation. In strange manipulation, you are doing something that looks like, how do you convert uppercase to lowercase? How do you do regular expression? How do you use the regular expression? How do you separate items? Let's say you want to create, you have names, first name and last name, you want to create emails. How do you combine these two columns to create emails? How do you do a lot of those kind of stuff? How do you do conversion? Like I talked about before, you have feet, you have meters, you have centimeter, and it's just height. People have entered it in several formats, several metrics. You want to convert it to just feet. How do you do this kind of conversion? How do you do what's it called, clustering? How do you do imputation? How do you do passing? How do you pass values? How do you do merging? How do you, let's say you want to merge two data sets or two tables into one, or somebody did one data set, another person did another one, but just a continuation. How do you append it on that, or how do you append it to the right? Those kind of stuff. Then you have derived variables. We call it calculated fields. So that's to say that you have somebody's let's say somebody's height, somebody's weight. A calculated field is going to be BMI. You want to get somebody's body mass index. So how do you get to do that? So it's called calculated field, because this field is not part of the data that you collected, but you want to create it. Or somebody's CGPA, somebody's points. Or you want to check if you should give somebody a loan. So you want to check 3 parameters, 3 columns, and now say a yes or a no. So that's called a calculated field. How do you do scaling? How do you do standardization? So these are some important concepts in the second, what was it called? In the second module. Then in the third module that have quite a lot of the job, we're going to be looking at 3 things. In terms of analysis, we're going to look at how do you communicate? Because as a data analyst, you're a storyteller. How are you going to do this communication? How are you going to tell this story? Are you going to be doing what we call mock-ups? How are people going to be accessible to this kind of visualization analysis you're going to be doing? Is it going to be an audio, or is it going to be visual? Like this is an audio visual. So it's just going to be you creating a visual and speaking to it, or is it going to be textual format? Is it going to be visual? If somebody has visual impairments, the person cannot read your report or understand fully your report if it's not textual. So at times you might need to combine the different accessibility formats so that all the different kind of audiences that you have can actually interact and communicate with your analysis. Now, when you do your reports are going to be for different kind of persons. Some are very technical people. For instance, my first degree is in mathematics. If I see any report, in 1 minute I can understand what the report is talking about, even though I'm a C-level executive. Then you have some C-suites or some C-level executives that are non-technical persons. So the way you approach communicating or telling the story for that data matters very well. So as a data analyst, you want to consider who is going to be consuming this data, right? So you have technical, non-technical, you have C-suite, you have individual contributors. So these are your different audiences that you can have. Then you have data that is sensitive and data that might not be sensitive. That's why at times when you collect data sets, things like name, you don't want to deal with that. Even if you collect that kind of data, it's not something you want to push out to the public, except it's a dummy, it's a representative kind of data. Then you might also want to be working keenly with key performance indicators. So what are key performance indicators? They're just metrics, things you want to measure. If you have student data, for instance, you want to know which student did the most. If you want to look at student data, which student studied the most hours. If you're looking at student data, which student what's it called, maybe offered the most course. Student's age, student's mode of entry into that particular course. So all of these are things that you might want to be looking at in terms of key performance indicators. They're just a way for you to better understand and interact with your data. Now, when it comes to statistics functions and methods, so basics are going to be you doing some kind of prescriptive, descriptive, predictive, inferential. So for prescriptive, you want to tell what we can do. That's after you've done the analysis. For descriptive, you want to tell the past. You want to explain the data set. Most of the times you do EDA, you do exploratory data analysis. In predictive, you want to tell the future, right? In inferential, you want to infer, just like the word says. Then for functions and measures, here, while you're trying to do your analysis, you're going to have some mathematical stuff. So you're going to have some logical kind of functions. For logical, that's where you do some kind of conditional stuffs. You can use dates, you can use strings. So that's going to be all for the module 3. Then understand that you might have issues with your, I've seen students over the years that have trained, some of the students we trained, I think last month or last 2 months, while trying to do their stuff, they're going to run into issues, right? You might have issue on site or while learning, trying to connect with your database or trying to connect with your data or trying to run some codes, having issues, or you can have your data or your dashboard even corrupted. There are some tools that you can use for this. It's going to be tools that can help you enable login, or tools that can help you validate your source, or you can also consult online resources. So these are one ways you can help to troubleshoot issues. Now let's look at the third one, rather the fourth one. Now, appropriate visual elements, very, very important. Appropriate visual elements. So when you're doing your visualization, you have different types of visualizations. So you could use charts, different kind of charts. So pie chart, bar chart, all of those kind of stuff. You could use maps. So maps are good for geographical data. So if you're going to be doing some geographical data, you want to use map. You cannot be talking about spatial data. You have longitude and latitude, and you're not doing visualization in terms of maps. You might have pivot tables. Anytime you want to do summaries. Anytime you want to do summaries, then you have to use pivot tables. Then anytime you want to tell a story in a simplistic format within a very short time, you want to do infographics. Right? So for design elements, you want to ensure that you have a way for people to understand the data. That's where label comes in. That's where legend comes in. That's where branding comes in. That's where color schemes. I normally tell anybody doing visualization that you should keep your color scheme very simplistic. You want people to be drawn to the insights that you're trying to create, not to be distracted by the too many visuals and too many shouting multicolor stuff that you have. So you can have simplistic color scheme, 1 or 2 color scheme, so that when you look at your visualization, it makes a lot of sense. So let's say data visualization. So let me show you something, what I mean. You see this particular visual, you see they're using a simplistic, like this one now is using some kind of bluish kind of color scheme. Yes, you have a little touch of other colors, but it's majorly just one color, right? So that's what you call a color scheme. Let's say Tableau. Good. So something like this, right? So you see the way this is. So it's just one color, right? I've stopped it. Just one color. I don't want to get distracted in this explainer. I would have opened my Tableau tool or my Tableau public view, and you can see some of the visualizations I've also done. You want to keep it simplistic. You also want to have labels. Labels will tell them, okay, anytime you see this, this is for this. Anytime you see this, is for this. Or rather legend. So for labels, you want to label your data. Imagine you have something like this. You have something like this. You have something like this. Labels, you want to say what this is. You want to say what this is. Then you also want to put, let's say this is 30. You want to say this is 40. You want to say this is 25. Sorry, I'm not with my writing pad here. So you are labeling all of this. So for legends, you can say, okay, anytime you see blue is for this, anytime you see this. Then you also want to brand, you want to color scheme. For branding, you might want to put the company logo behind to make everything very interesting. Okay, so that's that about design element. Now let's talk about our report. Now, the way people are going to use this data matters a lot. So like I said earlier on, in your report, you want to have executive summary. You want to have the portal, how you're going to deploy it. So I would normally advise you can use Medium to write the report. You could use Tableau or Power BI to do your visualization or your dashboard. Then you can see a way to like version your stuff. So because most of the times you can have improvements to your reports, so you want to versionize it, version 0.1, version 0.2, 3, like that. If it's major, versions dot or 00. If it's major, then 1, 2, like that. Then for your dashboard, you can have a kind of a static or something that is dynamic, something that is changing as the data is majorly live data, especially if it's coming from a database. Something we can watch and we can see it's trickling. You call that a dynamic dashboard. Now, I've talked about troubleshooting, but let's talk about troubleshooting in light of validation. So we can have issues. Excessive load time, slow refresh rates, stale data, corrupt data. How do you handle that? You want to do good data filtering. You want to validate your source, because if you don't validate your source can be off, and once your source is off, your visuals are going to be off. You can code review so that you write efficient code. You could do efficient data filtering. You see that when you do data filtering using some of these tools, the way you filter data can tell how many seconds you're going to have your output. So you want to efficiently do this. Now, the last one we're going to be looking at is data governance. I love data governance because it tells us how to manage the entire landscape. So how do we manage our data? How do we take care of compliance? How do we do data privacy? How do we do quality? So this is not just about the analysis, but it's about how it is done. So how do we manage stuff? Who controls what? How is it managed? How do we ensure compliance? So all of these concepts are so crucial for a data analyst. So for data management concepts, so integration very key. How do all of the different aspects put together? Then for documentation, we want to make sure that we have what we call data dictionary. Very, very important. Data dictionary. So data dictionary is going to explain the data set. Let's say you have a data set of 50 employees. A data dictionary is going to tell how many columns that you have, what kind of data set, what kind of columns that you have, how many rows that you have. Just in 2-3 paragraphs explains that particular data. And of course the lineage, the process through which the data comes in. Then of course source of truth, very crucial. Data versioning, I've talked about that. Metadata. So metadata is data that explains data. So at times you might want to have metadata for your data sets, you want to have metadata for your analysis, metadata for different stages of your data. So that if somebody looks at that data or sees that data or sees that output or sees that file, the person can understand what that is without actually opening or interacting with it. It's just like when you have a photo taken by your camera is just going to say IMG or IMG25, whatever. I can just put a date to it. So that's the metadata. It tells us that it's an image. It tells us from the camera, like I have a Canon camera, a DLSR camera. So what the camera is going to do is going to tell you that it's Canon, so. Going to tell you the image, tells you date. So that's metadata. It just tells us the type of camera that shot it. Even your phone, when you take a photo with your phone, it's going to leave some metadata. Then what's it called? Compliance is so key. So you have a lot of stuff as regards data retention. So data retention has to do with how long should we keep data. So if you have an e-commerce data set, employee data set, so depending on your sector, whether you're in finance, whether you're in healthcare, whether you're in public government, whether you're a private company, you're going to have different retention policies by different sectors. So if it's 5 years, if it's 7 years, so you must make sure that in terms of compliance, you comply to that. You cannot just delete data and you cannot use it again, right? So it's a big issue. You also have GDPR, General Data Protection Regulation. You must make sure that when you're collecting data or you're processing data or you're reporting data, you comply with GDPR. GDPR is European Data Protection Regulation that is adapted by most countries. It tells who should collect data, how they should collect the data, how they should store the data, how they should process the data, how they should transmit the data, how they should secure the data, the entire data life cycle, and who have right to it. You also have rights by the data controller, by the data owner, and all of those persons that are handling data. So that's what the GDPR law says. You also have the payment card industry data regulation. So for companies that are dealing with payment cards, you can have data sets that have their credit card details with them. They have expiry code. So how should it be handled? You can even see some sites if you can give your entire 16 digits and they can process your transaction for you. So how should that data be handled? Should we have somebody at the back end doing data analysis and the guy is stealing credit cards? So you should comply with that regulation. Then jurisdictional requirements. So most countries, most sectors are going to have requirements in terms of data, right? So you have data ethics, what you should do and what you shouldn't do. Then data classification. For you to even govern your data, you first have to classify the data before you govern it. That's how it should be done. So do you have private data? Do you have public data? Do you have secret data? What kind of data do you have? Then that will not tell how you are actually going to manage it. And of course, if you have an incident like a data breach is where data is stolen, data is pilfered, integrity is being compromised. That's where you have a breach. Someone that's not supposed to see a particular data is now seeing that data. So how do you report it? Most countries, most jurisdictions are going to have a way to take care of this, right? Then in terms of data privacy and protection practices, so there are a lot of things that you could do. You could do what we call a role-based access control system. What I call role-based access control, right? So here you're trying to say everybody at different stage of the data lifecycle have a role to play. So that's going to tell the kind of permission they are going to have on that data. Another thing you could do, you can actually encrypt the data, either in transit, at rest, or during processing. Then you can have a way that you use your data and you share it. The NIST, the US standard that talks about tech, NIST, they have a framework that have to also do with data. So National Institute of Standard Technology provide guidelines in terms of handling data. So you want to consult that to see what some of the best practices are. They also have several controls for that. Then how do you deal with sensitive data? So sensitive data can be personal identifiable information, or they can be personal health information, or they can be, so PIIs are going to be things like your age, like your credit card details, like those things that are very personal. Then health is going to be health associated data. So those are the sensitive data. So some practices are going to be that you ensure that you protect these items. Then one concept, one practice to also do is what we call anonymization. You want to anonymize data that you have, or you want to mask the data. So quality assurance practices. So how do you ensure that you have quality data? So you want to do requirement testing. So before you actually start collecting the data, you want to ask yourself what's requirement. So this takes us back to the very first item, which is data concept, or let me see just a second. Yes, data concept. So in data concept, we talk about okay, let me look at data acquisition. I want to look at objectives. So like I said, objectives, very, very key. So before you even start doing anything, you want to ask yourself, what are your objectives? Your objectives play a key role in how you do stuff. So you need to do that requirement gathering. Then another thing you want to do also to ensure quality is to do a user acceptable test or user acceptance test. That is to say that even when you collect data, when you visualize data, when you write reports, your client needs to actually accept what you've done. Then you can do unit tests. Unit tests is to check each aspect of your data or each aspect of your visualization or each aspect of your report to see if it complies with your earlier objectives. Then you can also do data profiling, where you actually do have some kind of metrics that tells quality. So quality is not what I say, it's quality. Quality is what you've defined in your objectives. So what is that quality? So now you're going to have some metrics for that quality, then you actually profile and you check that. Then you could do health check. You could also check your source controls, have some kind of controls in how data comes in. Then you want to also look at the ISO standard for data and see that you comply to it. Okay, that brings me to the end of the Data Plus Certification Curriculum Explainer. In the subsequent videos, I'm going to be looking at each of these objectives in detail and let you understand how you can study for this, pass your exams, and also have skill sets that will make you a seasoned data analyst. Don't forget to subscribe. Don't forget to share. You could write your comments on the comment sections, and I'll see you on the next one. Now, don't also forget, I'm going to be bringing you flash guides. I'm going to be giving you quizzes. I'm going to be giving you summaries. I'm going to be giving you infographics so that you can have a full grasp of the entire curriculum. If you want to join our internship programs, we have for data, we have for cybersecurity, we have for software development, even AI-driven software development. Reach out, and it's a premium session. Register and join us in the call. Thank you, and see you in the next one.